All right, we'll have a lecture on the heart. Let's try again. New unit. The heart is a part of the cardiovascular system, which is actually three components. Part of the cardiovascular system. This system is sometimes also known as the circulatory system. Part of the cardiovascular system, which has three components. The heart, the blood, and the vasculature. The 4 points up there. We'll study all three, but not in one chapter. The heart is its own chapter. The vasculature is its own chapter, and the blood is its own chapter. Okay? And they're all on separate tests. So the next test is on the heart. The heart is a muscular pump that circulates the blood. And just to give you some not random, but typical textbook numbers. Your heart beats to do that, and the heart typically beats about 75 beats per minute. BPM, or sometimes that's called the heart rate. And a lot of times these textbook numbers are based on the average man who is 5'10", 175 pounds. And you have to choose some kind of unit. That's usually what it's based on. And so a typical, what we call cardiac output, the heart's a pump, it's pumping out blood. That's the term, cardiac output. At that rate, putting out something like 5 liters per minute in the resting condition, the condition of rest, like you sitting there resting. You're not in a state of exercise. And, that's enough to sustain good blood pressure. With each heartbeat, it's called a stroke volume. The stroke volume is the volume of blood ejected by the heart, per beat. Per beat. And so with each heartbeat, which is beating at a rate of 75 per minute, the volume of blood ejected is something like 70 ml per beat. This gives you a rough idea of what the heart is capable of doing at that heart rate, if it's functioning normally. So that's one chapter, chapter 18. We'll talk about all about the heart today. But just to give you a preview on the vasculature of the blood, you're pumping the blood into the vasculature, into the blood vessels. So the blood vessels what what is a vessel? A vessel carries something. So the blood vessels are simply containers for blood. We all add the word flow to it, because blood must flow. Blood is never still. If blood doesn't circulate, a person suffers shock and dies, and people know this. So there's blood flow. So we kind of measure this in the clinic. I mean, there's different kinds of blood vessels, right? There's the arteries, capillaries, and veins. Those are the main ones. So when I say you have a cardiac output and you have a stroke volume, when the heart is pumping blood, it's pumping blood into the arteries that are attached to it. So arteries are receiving this cardiac output. Arteries always carry blood away from the heart. That's a rule you want to memorize, because that rule is always true. Other rules that students like to use are not always true. It can get confusing for you at times. But this rule is true. Arteries carry blood away from the heart. Okay, they're distributors. They're distributing all this blood that the heart is pumping to all the body parts. So the goal is to get this blood to the smallest blood vessels that have the thinnest wall, called the capillaries. That way the gases can exchange, metabolites can exchange by diffusion, and then the tissues can get their oxygen and their nutrients. And the tissues can also get rid of their waste. So these blood vessels are called capillaries. Now, to push blood from arteries to the tiny capillaries, it requires pressure. That's why the heart pumps to generate pressure. And that pressure is always measured. They put a blood pressure cuff around your arm. You're testing this pressure in the brachial artery. And the cuff squeezes your arm, right? We've all experienced this, I think. What they're doing is they're closing off the brachial artery. They're cutting off the blood flow just for a few seconds. And then they release the cuff pressure. And they're trying to see the pressure at which blood will start to flow past that artery, okay? Because that pressure is the pressure being generated by the heart. And it's always measured in two numbers usually, like 120 over 80. This systemic artery pressure. It's always measured in two numbers. 120 over 80. There's a high and a low. Because with each heartbeat, there's a period of contraction and a period of relaxation. So think of it that way. With each heartbeat, there is contraction and there's relaxation. It contracts to generate pressure, and then it relaxes because it has to receive blood for the next heartbeat. Remember, the heart can't pump blood unless it receives blood. So if you're going to receive blood, you can't be a high pressure thing. You can't get blood into you. So when the heart relaxes, this is when it fills with blood. It receives blood. I'll just put receives. Receives what? What do you think? The heart has one job, pump blood. It's got to receive blood. So when it contracts, you can pump it. Generate high pressures. So that having been said, the top number is the higher pressure when the heart is generating, we call it peak systole, but so the word for that when the heart's in a state of contraction is systole. when the heart is pumping. When the heart is in a state of relaxation, we call that diastole. When the heart it's relaxed and it's receiving blood. Okay, so I said it a couple different ways. So what's the top number? It's systole, the systolic blood pressure. And the pressure drop, it doesn't drop to 0, it only drops to 80 to keep blood flowing, is the diastole. So that is the pressure that pushes the blood to the capillaries. And one last thing about blood pressure, it's always units of millimeters of mercury. I usually don't put it, but I should put it since you may not know. Millimeters of mercury is a unit of pressure. In medical science, physicists use pascals. You can look it up. What pressure is, in this case, it's the pressure that a column, the pressure that will displace a column of fluid. In this case, liquid mercury. Okay, you can use water, but people always do that because that's the standard. So basically, you got pressure, and you have enough pressure to push blood to capillaries, which is an exchange medium. Things exchange, and we'll learn how specifically. Then you want to collect this spent blood, and you want to return it to the heart, and that's the job of the veins. Collect, quote unquote, spent blood, return it to the heart. So that's the other rule to memorize. Arteries carry blood away from the heart, veins return it. And it's called venous return. That's the physiology term. Cardiac output, venous return. So here's a common sense question. Well, I think it's common sense. If the heart is pumping 5 liters per minute, what is it receiving? 5 liters a minute. It's got to, right? It can only pump what it receives if everything's working normally. So that's the venous return. All right, so that's, basically, blood vessels. Arteries carry blood away from the heart. Veins return it. And, a lot of times you have arteries and veins in different regions of the body. They run together. So if they're together, blood is flowing in the opposite direction, right? Artery next to the vein, because they're going to different places. All right, so the blood, they're circulating the blood. Clear some of this out. Life-giving blood. In the average adult, you only have about 5 to 6 liters of blood that is circulating. It could double for a pregnant mom. That's not very much. 5 or 6 liters. If you're hemorrhaging, you lose 1 liter. You start to go into shock. So it's kind of precious. You don't want to lose any blood, right? People always say, maybe you hear watching TV, oh, you've lost a lot of blood, or you hang around hospitals. And what's a lot of blood? About 1 liter. That's a lot. You can kind of have these reflexes to keep your blood pressure up. Once you start losing too much blood pressure drops. And why is that bad? If there's no pressure, you can't push blood to the capillaries and you go into shock. Okay, so you need that pressure, but you need enough blood volume to keep the pressure up. That's why in the first test, you remember how I kept saying increase blood volume, increase blood pressure? I mean, this is why. You only have this much to keep pressure up. So the body is very well adapted to keep blood volume up so that the pressure will stay high enough. And The main thing in blood that every tissue needs is the oxygen, okay? For the cell metabolism, right? Like the citric acid cycle, the electron transport chain, oxygen is the final electron, etc. I mean, we know all that stuff in biology. But if cells don't have it, tissues die, right? If it happens in your heart, we call it a heart attack. If it happens in your brain, what do we call it? A stroke. It's a lack of blood flow, okay? The lack of oxygen is called ischemia. Lack of blood flow, basically, because you have a lack of O2, it's called ischemia. So you want to prevent that and make sure blood can deliver the goods, the O2. Now, the main thing in the blood that carries the O2 is the hematocrit. The hematocrit has the iron-containing heme that binds O2 and circulates it. So blood has the hematocrit. When you do a blood analysis, that's one of the things you measure. Blood is about half crit. Okay, crit's kind of the term. A quick estimate of the oxygen carrying capacity of the blood. It's about half. Now, the normal range of crit is 37 to 54. That's the normal range. It's a percentage, so there's no units. It's about half blood. So basically, they just take a vial of your blood and they spin it down. And all the crit gets spun to the bottom. I'll talk about that. But if you're anemic, you have low blood, it'll be like in the low 30s. Okay, and if you get too high, that causes other problems. But I just want you to know the normal range. And so there's a molecule inside. Well, the hemoglobin is basically the molecule of your hematocrit that's binding the O2. Hemoglobin. Hemoglobin binds O2. You can measure that directly. You could just kind of like break up the red blood cells. You can kind of like just look at the concentration of hemoglobin in someone's blood. That normal range is something like 12 to 18 grams per deciliter of blood. I think that's right, yeah. So 12 to 18 grams per deciliter of blood. So just to give you some numbers, oh yeah, blood carries oxygen. It's always measured. So these three work together: heart, vascular, blood. They are in their own chapters. So I teach them separately in chapters, but they all work together. So I like to kind of mention things about them before I talk about just one thing, right? Just to give you a good overview. Any questions on heart, vascular, blood? So the heart circulates the blood. Well, blood circulates. Blood goes around and around. But that wasn't always known, right? You know, if you read the old physiology journals from hundreds of years ago, they had all these weird hypotheses about what blood did. It circulates. It's a circuit. So, why is it cut off? Let me, hold on a second. Sometimes this fixes it. Unplug, replug. Nope. It's cutting off part of my screen now. Hold on a second. Okay, I'm going to have to use it for that later. Hold on, let me fire up the computer and just use this computer since this is having problems. let's do it. Okay, we'll just go with this. Fire it up. Yeah, that looks okay. So I want to use this figure to teach you how blood circulates. If you don't know already. And so they got the heart in the center, and they got the lungs above, and a picture of a man below, just to symbolize pulmonary and systemic circulation. And so what I have on the slide there is that the heart, with each heartbeat, the ventricles generate enough pressure that drives blood through a double loop vascular system. We can divide this double loop into two main circuits, pulmonary and systemic circuit. A circuit is a circle. Blood goes out, then it comes back. Blood goes out from the heart, and it comes back to the heart. Pulmonary circuit, start with that one. I mean, if you look at the heart, really on the bottom I say, you have a pump, it's a double pump, because you have a right heart and a left heart. Now the right heart has blue blood in it to symbolize the oxygenated blood, and the red is to symbolize oxygen-rich blood. And let's start with the arteries that take blood away from the right heart. So if you start there, we'll call this pulmonary circulation. Call it pulmonary circuit, pulmonary circulation. I'm going to use blue because the pulmonary arteries take blood away from the right heart to the lungs. I'm using blue, so I'm not going to write deoxygenated blood because that's what blue means in this figure. So if you need to write it because you don't have blue, write it in your notes. Pulmonary arteries, blood, away from right heart to lungs. As blood kind of filters down to the pulmonary capillaries, you can get gas exchange. So that's the only way to get oxygen into this deoxygenated blood. That's at the pulmonary capillaries. This is where the blood picks up oxygen. So I'm just going to write blood becomes oxygenated. So then it's the job of the pulmonary veins to collect that oxygenated blood and return it to the left heart. I'm writing pulmonary veins collect oxygenated blood, oxygenated. I'll just say return it to the left heart. So the left heart receives that blood and then pumps it. But I'm going to stop there because we went out from the heart and came back. That's the pulmonary circuit, right? Went out and back. That's one loop. So maybe I should draw a line. And then systemic circuit. So that it's the systemic arteries that will distribute this oxygenated blood to the whole body. Systemic arteries. And these are the ones where you're monitoring the blood pressure, the 120/80. Systemic arteries that are generating that pressure and distribute oxygenated blood to the whole body. Okay. So let's stop and recap. We started with the right heart. The first vessels that took blood away from the heart are the pulmonary arteries. You force it through the capillaries here to pick up oxygen, and the veins collect it and return. Now I said systemic arteries. I'm talking about this one right here, right? You follow that? And it's distributing the oxygenated blood to all the capillary beds of your body. So, you know, systemic capillaries. Okay, I'm going to draw systemic capillaries in blue. That's where you drop it off. We have gas exchange, and O2 is delivered to what we call the peripheral tissues. Now, then again, you collect this blood and return to the heart. That's systemic veins. Systemic veins collect spent blood and return it to heart. Oh, the right heart. Okay, you can see that from the figure. So that's the idea. That's how blood circulates. So the anatomy of the heart, most of the structures can be studied in a figure like this. This is the classic frontal section of the heart, so you can see all the internal features. We have a heart dissection on Monday. And so to get ready for that, I'll teach the anatomy of the heart, the cardiac cycle of the heart, and by the time Monday comes around, you should be ready to study it. Now, one thing that's deceiving about this picture is, well, let me get a heart model. one thing to know about our heart models is they stand on the stand in the anatomical position. This is not the anatomical position. This is just so you can see everything. So these come off actually, which is good. This is how the heart sits in your chest. So this picture, to make it look like that, this is how the heart is pictured here. But this is how the heart really sits. Like this, not like that. Like that, that's the picture. Okay, I just wanted to make that clear. Because I don't want you to think that blood up here in the atria goes down. It doesn't. Blood is received in the atria back here, then it goes forward. Okay. Okay, well, what I want you to know is, let me use the app to kind of teach this figure. It's a little better. What we can do is we can like pretend we're a drop of blood and we're flowing through the double loop. And when you get to the heart, here's kind of how it goes. So the new version of the app, it has the heart beating, which is kind of cool. So I kind of show that easier now. Turn some stuff on. So to use it, you have to go to artery, you have to hit plus, and it shows the heart in there beating. So to see it better, if I just hide the skeleton, so you can see the heart and some arteries there. Now if I just tap on something and see that, tap on something and just click heart, I got the whole thing there. What I can do is I can hide others, just so I can see just the heart. Okay. Now I can turn the lights off just so you can kind of see it better. So that's how the heart sits in the chest. So in the front, you see mostly the right heart. Okay, see that little fat pad there? That's an interventricular septum there. So I got right and you got left there. So basically you see the ventricles and the right heart mostly. If you turn it around back, those are the atria. All right, so most people know this. How many chambers does the heart have? I heard 6, that's wrong. That's okay, 4. Maybe yours has 6, that'd be awesome. 2 atria, 2 ventricles. So, you know, let's kind of like, when you study this, where do you begin? Let's start with the chamber of the heart that receives all the deoxygenated blood from the whole body. That is the right atrium. I'm going to highlight it. I'm going to tilt it to the side. This is the right view. When I highlight that part down there, that's like part of the right atrium. This is part of it too, but it's shaped like an ear, so they call it the right auricle. But in my mind, it's part of the right atrium. Auricle means ear, so they're just describing the shape of it. That part looks like an ear. Okay. I'm going to highlight it again. So that's what we're starting with, the right atrium. In terms of where it is, I mean it's posterior, right? Posterior aspect. Posterior heart. And some people call that, you know, the base of the heart. And, you know, this is like the apex. That's the base. And basically it's posterior. Now, functionally, it's receiving all the deoxygenated blood from the whole body. Receives deoxygenated blood from the whole body. Now there's two main veins that drain into it. Let me see if I can throw in veins here. But what's in green now is the superior vena cava. That's coming from the top there. That's one of the main veins. The one on the bottom there is the inferior vena cava. Those are the two main veins that are draining all the deoxygenated blood to the whole body. You should note those. Superior vena cava. Inferior vena cava. They're draining into it. It's quite clear from any picture you look at. There's another one in there. Okay. Let me get rid of the veins. Turn the lights off. Let me get rid of the heart wall there. So you look inside. I'm going to hide that. So this is kind of an interior view of the right atrium. This is kind of like getting you ready for the dissection. Because you're going to have to cut away part of the wall and then reflect back and see some things inside here. So all the blood in here. Well, first of all, let's look at this other hole here. There's a hole down there. It's kind of hard to see because you have a black background and point to it. There's a little orifice right down there. You see that? Now that orifice is for another vein draining into this chamber. It's called the coronary sinus. And it's draining all the deoxygenated blood from the myocardium, from the heart muscle itself. So that's important. So let me write that down. That is the orifice of the coronary sinus. A sinus is another type of blood vessel. It's a vein, basically. So these three vessels are draining blood from the whole body, and then the coronary sinus draining the deoxygenated blood from the myocardium back to the right atrium. Myocardium is the word for heart muscle. Now, as I turn the lights off again, it's kind of the best way to see things on this app. So the lights are going to go off and on a lot. Do you see how the internal appearance, part of it is smooth and part of it is kind of rough? The smooth part, well, it doesn't have a name you have to know. See this roughened part right up here? It looks like someone took a comb and raked the heart muscle. So that's called pectinate muscle on the inside of the auricle. Okay, and that's something you have to identify on your heart on Monday. So write down pectinate muscle as a structure to know for right atrium. The muscle has a combed appearance. It just describes the appearance. That's what pectinate means, comb-like. The other thing to note, I think they'll allow me to highlight it, is there's a little depression right there. It's highlighted in green. Okay, that is called the fossa ovalis. It's a remnant of fetal circulation. I'll teach fetal circulation later, but just note it for now. Fossa ovalis. It's kind of a depression in the right atrium. A depression, a remnant of fetal circulation. So as blood is received by the right atrium, the atria, both atria, right and left, they can generate some pressure and then push the blood to the ventricle there. Okay, so most of the heart is the ventricles. And if I rotate just a little bit, you can see that pathway of blood flow. I'm going to rotate just like that. Now, do you see that valve opening and closing? Let me highlight one cusp. There's one cusp. If that's one, how many are there total? 3. So that is called the tricuspid valve, also called the right atrioventricular valve. So blood flows forward through that valve into the right ventricle. So you should note that cusp. It's called the, it goes by kind of names. It's a valve. There's going to be 4 valves you have to know. This is the first one. Yeah. So I'll put blood flows from RA to RV, RV is right ventricle, through this valve, through the tricuspid valve. Another name for it is the right atrioventricular valve, because it's a valve between the atria and the ventricles. I'll say right AV valve, you can call it that. So blood flows through there, and then, well, the whole purpose of a valve, what valves do in general is they prevent backwards flow of blood, okay? So when blood flows from RA to RV, the valve is open. And that can happen. When the valve is closed, it prevents this regurgitation of blood backwards. So long. So when the valve is closed, it prevents the backwards flow of blood from RV back to RA, which can happen if you have a leaky valve. Might need a valve replacement, they can do that. But anyways, this is a nice illustration. You can kind of see that happening there. That's the job of all valves, prevent backwards flow of blood. In this case, keep it going forward, prevent it from going backwards back into the right atria. Here's a side view of the heart. So what I'm going to do is, what I have highlighted now is most of the wall of the right ventricle. I'm going to hide it so you can see inside the right ventricle. So here's kind of the other view from the right ventricle. I see 2 valves now, do you? I mean, I saw the one we just looked at. Right here. Do you see how this valve, it has attachments to the ventricular wall through these tendons and this little nipple-shaped muscle? That's something that's unusual about the AV valves, okay? Like that. So as you get into the right ventricle, so far, we're a drop of blood. We're in the right ventricle. I'm sorry, we're in the right atria. We go through this valve to the right ventricle. That's where we are. The right ventricle. We're in the right ventricle. However, when you look inside the right ventricle, you can see that the tricuspid valve is attached to the RV surface, or I should say RV internal surface, through chordae tendineae. Chordae tendineae. Sometimes these are also called the heartstrings. Although that's kind of a term you can't use on a test. Chordae tendineae is the term. So the chordae tendineae, well, it starts like this. You have a cusp of the valve, which is the valve itself. Cusp. Then you have these heartstrings. Chordae tendineae. And then you have this nipple-shaped muscle called papillary muscle, which means nipple. Papilla means nipple, papillary muscle. So those are all part of, well, the valve is the cusp, but it has the chordae tendineae too. It's a different structure. It's a tendon, it's a tough, white, fibrous tendon that attaches it to this papillary muscle on the inside of the right ventricle there. That's important to know, because when I had you identify the valve, sometimes students have trouble finding it. But if you can find the heartstrings, let me zoom in on one of these. Yeah, there's the nipple-shaped muscle, the papillary. Okay. Let me see if I can highlight the heartstrings. There you go. Those are the heartstrings. Go ahead and pluck them in your sheet part on Monday. They're really tough. I don't think you can break them easily. Probably have to really tear it. You have, that's a cusp, right? So you have cusp, you have the heartstrings and the papillary muscle. Look at the internal appearance of a ventricle. It's not smooth. The muscle is like crossbars of flesh. Okay, that's what people call it, and it's called a trabeculate carne, which describes the internal appearance of both ventricles. Crossbars of flesh. So note V. So I'm going to erase this, but be able to identify all these. Also note trabeculate carne. Crossbars of flesh. It just describes the internal appearance of both ventricles. Okay, now the right ventricle, it's receiving blood. Its job is to receive blood from the RA and then pump it into the artery that's attached to it, the pulmonary trunk, which is going to get that blood to the lungs. So the function of RV, I'll say RV receives blood from RA and pumps it to the pulmonary trunk, which is an artery in its function. Pulmonary trunk, which is an artery. Sometimes they don't call arteries, and veins. They'll use other words like sinus or trunk. Anyways, let me show you the path flow of blood. And then rotate it like that a little bit so you can see the whole thing. Okay, I'm going to use this 3D pen function here. So blood flows forward. See, it's not letting me, here it goes. And then it flows up. So that's kind of the pathway of blood flow, right? It kind of goes forward and then up. Now, the right ventricle, the shape is it kind of funnels. Let me see if I can rotate it a little bit. The part where it funnels has a name. It funnels like a cone, right in this area. So right in this area, if I put a sticker and I say identify, this is called the conus arteriosus, this part of the right ventricle. I would note that. It's on your study guide. It describes the rough internal appearance of the ventricles. So you look at something, is it rough or is it smooth? Describe that. Is that rough or smooth? It's rough. It's not smooth, and we call it trabecular cardia. Okay? And if it's rough here in the atria, what do we call it? The pectinate. Okay, so these appearances have names. So the thing I just mentioned is conus arteriosus, know that. This is the part of the RV that kind of funnels up into the pulmonary trunk, into the artery. Part of RV that funnels the pulmonary, that funnels into the pulmonary trunk. I'm going to zoom in there. To get into the pulmonary trunk, we have to go through this valve. This valve has 3 cusps. There's 1 cusp. There's all 3 cusps of the pulmonary valve. The full name is pulmonary semilunar valve because one of those cusps is shaped like a half moon. Okay. So anyways, note that valve. Pulmonary semilunar valve. So blood flows through this valve into the pulmonary trunk.
let's see if I can get rid of my 3D pen there. So there it is, highlighted in green. That's the pulmonary trunk. Now it's going to both lungs, okay? It's going to distribute blood to both lungs. So it's the pulmonary trunk, it's an artery, it's taking blood away from the heart. Is blood at this point oxygenated or deoxygenated? Deoxygenated is correct. If you go to the lungs to get oxygenated, the pulmonary veins collect that blood and return it to the left atrium. So I'm going to go around back here. This is pretty much a posterior view of the heart. Okay, and if you're looking at it from behind, this is basically the right side, it's the left side. So this is the left atrium. Okay. The left atrium is receiving all the oxygenated blood that came from the lungs. You have 2 left, 2 right pulmonary veins that drain into the left atrium. Left atrium receives oxygenated blood from 2 left, 2 right pulmonary veins, 4 altogether. Yeah, question?
Yeah, so the pulmonary is the liver valve brings the oxygenated blood into the lungs.
No, it brings it into the pulmonary trunk. The pulmonary trunk will branch out and then bring it to the lungs. Okay, let me see if I can show you that. For now, we have 2 left, 2 right pulmonary veins. Turn on respiratory.
I have a question.
Yeah, go ahead.
From the pulmonary trunk, we only have 1 left and 1 right artery going to the lungs, right?
Yeah, let me show you that. You are correct. It's kind of hard to see. So do you see you have 1 pulmonary trunk? Now branching off of that, if I go to a posterior view, from the 1 pulmonary trunk, you have a pulmonary artery going to each lung. Okay, one on disoriented, but you have 2 pulmonary arteries branching off 1 pulmonary trunk to go to each lung to get oxygen. Okay. And then what I was saying is, oh, well, once you get oxygenated, you have to return that oxygenated blood back to the left heart. There you go. There's 2 of them on the right side. There's the other 2 pulmonary veins on the other side. Okay? All right, so when we get to pulmonary veins, at this point, is the blood oxygenated or deoxygenated? It's oxygenated. The 4 pulmonary veins are veins that carry oxygenated blood. In pulmonary circulation, the veins carry oxygenated blood. So I want to hide part of the atrial wall there. Let's hide that. Let me give you the side view of the left heart. Turn the lights off a little bit, and what you can see is I removed part of the wall, and it's clear to see there's a left auricle, just like there's a right auricle. Okay, here's the auricle, there's the atrium. Those are two pulmonary veins draining into it. So note the left auricle as well. And by removing part of the wall, I want you to see the bicuspid valve on the other side. You see the valve opening and closing. I'm going to highlight the whole thing. There's one cusp. It's the whole thing. You can call that the left AV valve or the bicuspid valve. So blood is flowing forward from left atrium to left ventricle. Blood flows from left atrium, LA, through the bicuspid valve, and you can also call that the left AV valve. To the LV. Blood flows from LA to LV through the bicuspid valve. So let me give you a side view of the left heart. I'm going to highlight most of the left ventricular wall. I'm going to hide it so we can kind of see on the inside like you're doing a dissection. And what you see, if I turn the lights off, you can see some of the same things left to right. Now the shape is different. The right ventricle shape is different from the left ventricle shape. But blood is flowing forward, it's going to go up this way. But anyways, that's the valve. Do you see the chordae tendineae and the papillary? You have it on the left side too. Do you see trabeculae carinae? You have it on the left side too. I'll write that down. I'm not going to write it. I'm a little lazy, but I just want you to know. I set it for one side, the right ventricle. It's on the other too. Okay, I can see it right here. I just want you to know that. It's on both sides. For that matter, you have pectinate on the right auricle. Do you think it would be on the left auricle? Yeah, they don't show it very nicely, but I see pectinate in there. The left auricle. So note that too, if you want to make sure you're complete your notes. Look for pectinate on the right auricle and the left auricle. Look for trabeculae carinae on the RV, LV. Look for the chordae tendineae and papillary on that side too. So I tilted it just right, so it's hard to see. I got it so I could see our two valves. The one I just mentioned is the bicuspid. Blood is flowing here and then pumped up through that artery, through that valve into the artery right there. So I'm going to highlight it. That is the aortic valve. The full name is aortic semilunar valve. Now on the app, there's a couple of holes there. That's a mistake. Okay, you have to fire the programmer. I'm just kidding. I'm not serious, but it's a mistake. lose their job because I said something. But anyways, that is a mistake. I don't want you to ask me, what's that hole? Okay, that's what I'm saying. Well, anyways, do know the name of it is the aortic valve, aortic semilunar valve. Blood, turn the lights on. Blood flows from the LV, the left ventricle, through the aortic semilunar valve into the aorta. So that's the name of the artery that's attached to the left ventricle. So I'm just going to reset here. The artery has different parts. We'll get into it later. Let me just kind of highlight one there. Okay. The artery is the aorta. The artery here is all of this. It's going all the way down. Let me turn the lights off. It's out of sight there. It's behind the pulmonary trunk. It's going all the way, boom, all the way down. There's these three branches coming off here. Let's talk about those now, yes. Well, we can do it later. I have a slide for it later. I just want to stick to the heart. Know that this is the aorta. Okay, another thing here. There's a connection here that's not used anymore. It's a connection between the pulmonary trunk and the aorta. It was used during fetal circulation. It's called the ligamentum arteriosum. So let me see if I can highlight that. Right there. You'll have to find it on your sheet part. Ligamentum arteriosum. So look for it on the anterior heart, I guess. Let's see. Connection between pulmonary trunk and aorta. So when you're looking for it on your sheet part on Monday, you have to find pulmonary trunk and aorta first, right? Just kind of peel them apart. You should be able to see it there. This is another remnant of fetal circulation. Yeah, you're not using it anymore. We may come back to the app, but I want to go back to the PowerPoint slides. So I used to kind of do all that from this picture, and I realized that the app is a little better. First of all, you can see the heart beating. Let's go back, and I should probably mention that, right? And even with the lights on, you can see that the two atria contract, then the two ventricles, never all four at once, okay? That's how blood is pumped. Two atria contract, then the two ventricles. If you look at that long enough, you can figure it out on your own. I just want to say it. Because that's different than what I'm about to teach next, which is basically, we already kind of talked about it, but now we're going to get the heart into play here. This is kind of showing you following a drop of blood through both circuits again. And now that we have some of the heart anatomy under our belts, we can kind of go through it. If you follow blood through the double circuit, it starts with, I'll abbreviate SVC and IVC. Superior inferior vena cava. Blood at this point is deoxygenated, and it goes to the first chamber of the heart, the right atrium. And I'm using blue for deoxygenated blood. I'm just following this. Start here. Blood flows into here. Now from that chamber, blood flows through an open tricuspid valve. It goes to the RV. And through the RV, it's pumped through an open pulmonary valve, pulmonary SL valve. To the pulmonary trunk. You have one pulmonary trunk. It divides into two pulmonary arteries that go to each of your lungs. Well, anyways, the figure, it goes two lungs. And you force blood through the pulmonary capillaries. So I'll draw pulmonary capillaries in red and blue because you're picking up oxygen. That's where blood is oxygenated. Now, this oxygenated blood is collected by the two left, the two right pulmonary veins. The pulmonary veins are draining into the left atrium. The left atrium, when the valve is open, blood flows through an open bicuspid valve. Into the LV. The left ventricle. And when the left ventricle generates pressure, it pushes open the aortic valve, the aortic semilunar valve. Into the aorta. And the aorta will then pump blood to the systemic capillaries. And then you're done. So we went through the double loop again, right? We just kind of just looked at the heart. Well, if you're going to do good in this test, you should be able to do that walking in your sleep. Okay, it goes this way, it goes through there, all the structures, all the valves. And sometimes the valves get a little confusing. Students always mix up tricuspid and bicuspid because they have different names, right? What do we say we could also call the tricuspid valve? The right AV valve. The bicuspid valve we could also call the left AV valve. It's also called the mitral valve. Goes by all of those. Someone thought it looked like a bishop's mitre, so mitral valve. We call it all of that. And one easy thing to help you to buy a tri thing is lab rat. Left atria bicuspid, right atria tricuspid. Okay? So you don't confuse the bi and the tri.
And we can use either one. We
Yeah.
don't have to. Okay.
That is correct. They're all acceptable terms. Well, let's put the heart in the chest and see what it looks like. I got a couple of pictures from the atlas there to help us with this. One is just a frontal view, just kind of removing the chest plate. This picture, what I wanted to impress upon you is when you open the chest, people think you'll see the heart beating in your face. You don't. You'll see it at all. First of all, it's obscured by the lungs. Second of all, the heart is covered by the pericardium. You can probably see it beating inside the pericardium, but you can't even see the heart, is the point. Now, in this sectional view, this transverse sectional view, you can see all four chambers of the heart there. You can see how the heart's positioned in the chest. I'm going to use this figure here. I'm going to zoom in on that figure there. Okay, so this is a sectional view. You got lungs, you got four chambers of the heart. We use the pen function here to draw on this. Okay, that one is the RA. Okay, that chamber there is the RV. That chamber there, therefore, what is this one? This third one. Left A, and that's the L. Okay, so I want you to be able to recognize in a sectional view like this, this is the front, this is anterior. So the right heart is facing anteriorly. That's most of what you see when you see the heart sitting in the chest. Okay? Let me write that on the board. So that's kind of why I put that figure in. I want you to see that the right heart faces anteriorly. And also, I didn't talk about the coverings of the heart yet. When the heart sits in the chest cavity, it's covered with the pericardium. The pericardium, if you use this water balloon analogy, which is a good one, if you take your fist, on the heart, which is about the size of your fist, and you just kind of shove it in the water balloon, and the water balloon completely envelops the heart. That's pretty much what the pericardium is. Okay? There's the part of the pericardium that is intimate with the heart wall, becomes part of the heart wall, and there's this outer part there. And in between, it's fluid filled. Okay, so that's the pericardium, the covering of the heart. You have a figure that teaches you the different layers of the heart wall, including the pericardium. But let's talk about that first, the pericardium. This will show you on the app. It's a little prettier. See, I think if you go add the layers, see how the heart's covered now? And you can kind of see the heart beating in it. That's the pericardium. Okay, it covers it. And it anchors it inside the chest. So what they're showing you here, they're taking, what you have to understand is, it's covering the heart, but this covering called the pericardium is attached to the heart on the great vessels of the heart up here. It's attached inferiorly to the diaphragm down there. Okay, so that kind of keeps everything in place. attached to the great vessels of the heart. And I've already said them, and not all at once, but the great vessels of the heart are the SVC, the pulmonary trunk, and the aorta. Okay, so it's attached to them up there. And inferiorly, the pericardium is attached to the diaphragm. Attached to the diaphragm. Inferiorly. Now what they do is they take a little piece of the pericardium attached to the great vessel of the heart, and they show it to you right here. It's the pulmonary trunk. So you can see how a part of the pericardium is attached to it. It's a fibrous attachment there. So all of this is considered, well, this first part is just the pericardium. It has different parts. The fibrous part of the pericardium, well, they just call it fibrous pericardium. Let's just go with that. Oh, I should be clear that there's parietal pericardium and there's visceral pericardium. Okay. The parietal pericardium is the outer part, the visceral pericardium is inner. Okay, so the parietal pericardium has a fibrous part and a serous part. Okay, fibrous serous. So two parts to the parietal pericardium. So I'll listen to there. Fibrous part, serous part. It's serous membrane. It means secreting serous fluid. So then you have the visceral layer. If you follow the serous pericardium, that's part of the parietal part, where my pointer is, and you follow it, you get to the great vessel of the heart, and it kind of turns in and is on top of the heart wall. That is the visceral pericardium. Visceral layer, pericardium. It is also serous. What does that mean? It's secreting a serous fluid. Because the space in between parietal and visceral is the pericardial cavity. Pointing to it right there. The space in between parietal and visceral. Pericardial cavity. I'll describe it as a fluid-filled space. It's between the parietal and visceral. Between parietal, visceral, pericardia. If I ask what's contained in the pericardial cavity, don't say the heart, say the fluid. Okay? It keeps things slick. As the heart beats, it's pretty frictionless in there. You can't have problems with this pericardium. You get some trauma and you bleed into this cavity. It's called a cardiac tamponade. You're basically crushing the heart, making it difficult to beat. And what's a tampon in female hygiene? You bleed into it. A cardiac tamponade, you're bleeding into this space and it's not good. Okay. But anyways, that's a clinical side note. I'm not going to write it on the board. I just want you to know the structures. Okay, parietal and visceral, pericardial cavity. Let's talk about the actual heart wall itself. Okay. Heart wall, layers. Going from outer to inner, the outermost layer is the epicardium. Now, the epicardium is one and the same as the visceral pericardium. Same thing. They just, for purposes of teaching, it's the same thing. Cardium is the visceral pericardium. Now, we used to get our hearts. We used to get the whole thing, all the pericardium. Now, for safety reasons, they're worried about the heart containing worms. You don't want to surprise, oh, look at that. So they remove the parietal pericardium, and you only get it with the visceral pericardium. You don't even notice it. It's just the visceral pericardium. It gives the heart a very glistening, shiny appearance. Okay, like a very delicate saran wrap that envelops the heart. And this is one where it's a bonus structure on the dissection. If you can remove a portion of it, separate it off the heart wall, I'll give your group like 2 bonus points. Because it's hard to do, not everyone can do it. So I don't make it mandatory. Peel it off of there. I'll show you a picture of that later. Let me see. I can fast forward to it now. So put the cat out of the bag there. Do you see it? You think you could do that? That's a student did that. He said, oh, wow, that's good. Got my camera, got my phone, take a picture of that. Then another student said, oh, I could do better than that.
Oh my gosh, wow.
And that has not been outdone. Okay, we'll go back. So that's a couple bonus points. And a lot of students try, and in the past, not speaking about you guys, in the past, efforts have been kind of not good, and you get nothing. But if you do something like that, or anywhere close to it, you'll get bonus points. I'll be impressed. It's hard to do. It takes good hands to do it. We'll see what happens on Monday. Well, anyways, the bulk of the heart is the muscle, the myocardium. Okay, so the myocardium is basically the cardiac muscle. I'll teach kind of like the physiology of it later, just as a layer, bundles of cardiac muscle. Now, when you learned about muscle in 430, it was about like skeletal muscle, and muscles have actions. They move joints, right? Flex, extend. And the heart doesn't do that. The cardiac muscle's job is to generate pressure. It squeezes the ventricles to generate pressure. Okay. It generates pressure during systole. That's the top number, the 120. Okay, the inside of the heart wall, the part that touches the blood, is the endocardium. Touches the blood that's flowing through the heart. Okay? So that's how, that's the heart wall. You got the pericardium, and you can kind of see how it sits in the chest cavity with these pictures here. I inserted these pictures. If you remove the shoulder on the left and the right side and look in the thoracic cavity, you can see the heart and the pericardium right there and right there. All I really want you to know from this is what's called the red side and the blue side, because on the left side, you see the artery, the aorta. But on the right side, you see mostly the superior vena cava. Okay? So you start to orient yourself what's left and what's right. On the left side, see the aorta. And on the right side, you see the superior vena cava. SVC. Now, in this picture, it's a good one to teach. You cannot see the inferior vena cava. This big hump is a thin membrane called the diaphragm. It's your breathing muscle. And under there is the liver. And so the inferior vena cava, there's a caval opening in the diaphragm. And as soon as the inferior vena cava goes through the diaphragm and is in the thoracic cavity, it's already in the right atrium. So you really can't see the inferior vena cava in the thoracic cavity. So let me note that. I think it's a study guide question. The inferior vena cava has no length in the thoracic cavity. All right, let's take a break and pick it up here.